Do subscribe to Ekeeda channel and press bell icon to get updates about latest engineering, HSC and IIT JEE main and advanced videos.
Friends, let's solve question number 10 of 2014 Physics Paper 1 Generally Advanced, question number 10. So let us start question number 10. Students, let us solve the question number 10 of 2014 JEE Advanced Physics Paper. So in this question we have two ideal batteries of EMF V1 and V2. So they have no internal resistance. Three resistances are connected, R1, R2 and R3 are shown in figure. The current in resistance R2 would be 0. So here it says the current should be 0. If which of these is correct, is or are correct. So options are more than one option correct answer. So we have to see all the options. So first of all, let me draw the diagram again. We'll use Kirchhoff's voltage law to solve this question. KVL will use. This rather seems to be a very easy question where with two batteries here and three resistors connected. Now because they don't have internal resistance, I will think of connecting using KVL for this. So to apply KVL, I will we have to apply KVL, and to apply KVL, Kirchhoff's voltage law, we'll distribute the current. Suppose the current that is flowing through this is, suppose I is the current flowing, and from here to get distributed here, suppose the current is I1 and the remaining current here that flows is I minus I1. This is how the current moves in this fashion. So this side it is I minus I1, I1, again it is I. Now we'll apply, write the equation with involving V1 and V2 separately, and because V1 and V2 for no current, this point and this point would have same potential. That we'll see how which of these options are possible. Obviously that depends on the resistances values also. So I'll consider this as my loop number 1 and this is my loop number 2. If I see the loop number 1, that is I'll start from here and reach this point again by moving in clockwise sense, in the same sense as the current is flowing in the branch of the circuit. If that is the case, here it is minus IR1, here it is minus I1 R2, and this is plus V1 equals to 0. So from here I have equation like V1 equals to IR1 plus I1 R2, equation number 1. So if I apply, this is to loop number 1, I applied. Now I'll apply to loop number 2. This is the loop number 2. Starting from this point, I'll move like this, or I can move like that. So let us say I am moving in this sense. That is again this becomes positive I1 R2. So I'll write I1 R2 plus of V2. Here it is minus of I minus I1 into R3, and that becomes 0. So from here I write V2 as I minus I1 into R3 minus I1 R2. This and this goes to the other side. This becomes positive and this becomes negative. And V2 is there. This is equation number 2. If I solve this, remove that, so I will have I1 of R1 and R2 something I'll get, but then we'll do that later on. Now from here, to see the potential difference between these 2 points, have to be same for current to be 0 in this. So, and because the relations are V1 V2 or V1 minus V2 whatever, so we'll see what is possible is write the equations V1 and multiply with R3. So I'll do one thing, I will write the equation of V1 for you and V2. V1 equation is IR1, that already we have got it, I2 I1 R2 I1 R2. This is equation 1. In this equation 1 that we obtained earlier, I'll multiply R3 throughout the equation. So throughout the equation I am multiplying R3. If I multiply R3, I'll get V1 R3 equals to I R1 R3 plus I1 R2 R3. This is equation number say 3. Similarly, the V2 equation is I minus I1 into R3 minus I1 into R2. This is the equation we got from KBL last time, and now to this I will multiply R1 and see what I am getting. To this equation I am multiplying R1, so this will become V2 R1 equals to I minus I1 R3 R1 minus I1 R1 R2. So this is equation number, okay, let me simplify that, because I want to be this current I want to be 0, so I have to separate I1 from these equations. From that, if I little solve this equation, this becomes I of R1 R3 minus I1 of R1 R3 minus I1 of R1 R2. If I take common here, I equals to R1 R3 minus I take common I1, this is R1 R3 plus R1 R2. This is my V2 R1. This is equation number 4. This equation is this. This equation is this. We can see that if this one is same here and here, if I subtract these two numbers like B1 R3 minus B2 this, so this will cancel out and this is added to this, and we'll have equation involving I, because I have eliminated I1 and I have eliminated I, because I am not interested in this I am interested in this I1. So for that I subtract 4 from 3, that is I am going to do the operations of equation number 3 minus equation number 4. If I do that, just I am writing it for you, it will be V1 R3 minus V2 R1. This side this minus this, so this will cancel with this plus this will be there, so I'm writing I1 R2 R3 plus of this one. So I will get 3 minus 4. I will get this one, I1 R1 R2 plus R1 R3. Now from here I will separate this I1 and I will write I1 as in bracket R1 R2 plus R2 R3 plus R3 R1. Okay, and this is V1 R3 minus V2 R1. From here I will have I1 equals to this value V1 R3 minus V2 R1 divided by R1 R2 plus R2 R3 plus R3 R1. This is the expression I am getting. And now the options. If I see the option number 1, because I want to know current in resistance R2 would be 0, so here for this to be 0, this for I1 has to be 0, this has to be 0, this has to be 0. That implies V1 R3 should be equal to V2 R1, first of all. But in this option nothing such is given, so I'll think of something else. This will be 0 if I consider option number A. This is given V1 equals to V2 and R1, R2, R3 are equal. We are not concerned about R2 here, we are concerned about R1 and R2, and R1 equals to R2 equals to R3. If this is the situation, R1 and R2 are same and V1, V2 are same, then V1, R3 can be written as V1 R1 minus V2 is equal to V1, so which is V1 and R1. So that means if these two numbers are same and these two numbers are same, that means the difference will be 0. In that case I1 will be 0. So option number A is correct. Option number A is correct. Why? Again you can see here V1 and V2 are same and R1 and R3 are same. So in place of R3 I will write R1, in place of V2 I will write V1. So this equation will become V1 R3, instead of R3 I will write R1 minus V2 I will write V1, R1 I will write R1. You can see that both are matching, it will cancel, it will be 0. 0 upon anything will be 0. So under this condition that V1, V2 are both the batteries, the current will be 0 under condition that both the batteries should be same EMF and R1 and R3 should be same. R1 and R3 should be same. In that case it is possible, irrespective of the resistance over here, it is not necessary condition that R2 should be 0. R2 can be any value. So that means this is the same battery and this is positive and this is same value, and this is positive and this is the same value. That means this resistance is connected with the negative terminal of this battery and this is the positive terminal of the battery. This battery tries to send current in clockwise sense and this battery tries to send in clockwise sense. So in this branch the current is from left to right and here in this section it is from right to left. So in one branch current cannot flow in both the directions, and this is possible only when the potentials are same, the batteries are of same and the resistance is also same. Then only this is possible, current will be 0. That is possible, quite possible. The situation is something like this. You can realize the situation is like this, that if I have a battery over here 10 volt and resistance is suppose 2 ohm, and I have another battery over here whose is 10 volt and resistance is 2 ohm, then this is suppose V1, this was V2, and this is R1, this is R2. So in this case V1, R1, V2, R2 are same. If I connect any resistance over here, then current through this will be 0. because this try to send in clockwise, this will be actually positive this side. Okay, this current sends in current in this direction, this is current in this direction, so there is no current in this because this both will have the same potential. So this is exactly the situation that is taking place here. If I see the option number B and see what is possible, again I have to look at the equation that I have drawn. The equation is like this. This is V1 R3 minus V2 R1 divided by the whole product combinations of the resistances below V1 R3 V2 R1. So I write that I1 equals to V1 R3 minus V2 R1 divided by the combination of resistances. I don't require to write those numbers because that is not required in this situation, because that number is never going to be 0. So even if I omit that number here, otherwise I write that for you: R1 R2 R2 R3 and R3 R1. So I1 is this, and this one will be then if I see the option number 2, because we have to go by the options, V1 and V2 are same. Okay, then V1 V2 are same, then I can write here also V1. Then this will be 0 only when the product is 0. This product and that product is 0. Again it says that R1 is 2R2 and R3. R1 is R3. It is very interesting and some type of illusion type questions. R1 is R3 here, R1 is R3 here. I told you that this R2 is not affecting the balancing because the current has to be 0 here, so the resistance of it is not going to affect uh, affect the current that is flowing, because we are maintaining the potential difference here same. So whether it is R2 here or R2 here or any number of R2 here, we are not concerned with that, because the I1 will be 0. The I1 current here, suppose the current is I1 will be 0 only when these two resistances are equal and this voltage are the same. So therefore irrespective of R2, this should be the right situation. That again the option number B, which says that V1 is V2 and R1 is R3 equals to whatever times R2. This is also correct option, and for that case also that will be 0. So this is also right answer. Now we see the option number C. If I check the option number C, the option number C is V1 is 2V2. Then the option number C will check. It says V1 equals to 2V2. I'm just writing it for you. This is the thing I'm writing it for you. V1 is 2V2 and 2R1 is 2R2 equals to R3. So this is what is given in the question that we have to check. Now again I have to use the equation that we have already got, that whether this is correct or wrong. I1 I have got as V1 R3 minus V2 R1 divided by the whole bunch of the product of resistances R1 R2, R2 R3 and R3 R1. If I see that if I put V1 equals to 2V2, V1 equals to 2V2, then I'll put here V1 equals to 2V2. It is 2V2 R3 minus 2V2 R3 minus V2 into R1. But for R1 I will just say this number is same here, this whole thing is same here. You can see that this I will be 0, I1 will be 0. So here this number to be I1 to be 0, this number must be equal to this number. So from here, if I compare that, then R1 must be equal to, for this to be 0, for I1 to be 0, I have to equate these two numbers. 2V2 R3 must equal with V2 R1. That means R1 must be 2 R3 under this condition. But here R1 is not 2 R3, but if I see here properly, then here I am getting R1 equals to R3 by 2. Here I am getting R1 is R3 by 2, but we require R1 is 2 R2. So this is not matching with this. So option number C is wrong. Because for R1 equals to twice R3, then only it will be 0. But here R1 is not twice R3, it is half of R3. So this is not going to be 0. So option number C is incorrect. This option is incorrect. Let us see the option number D. In option number D, we have again some kind of relations that is there. I'll write the option number D for you and see checking it whether it is same or not. The option number D says 2V1 is V2 and 2R1 is R2 equals to R3. That will check it out. The question was we already had that for I1 to be 0, for I1 is equal to V1, what was we got that time, V1 R3 minus V2 R1 divided by the whole bunch of R1 R2. For this to be 0, this upper one should be 0, and if I put this condition over here, that is for this to be 0, for I1 to be 0 implies V1 R3 must be equal to V2 R1. But here it is given that 2V1 is V2, so V2 in place of V2 I'll write 2V1. In place of V2 I'll write 2V1. So if I write 2V1 and R1, then I can cancel V1 and R3 I am getting 2R1. This also should be the case. So here you see that R3 is 2R1. It's fantastic. R3 is 2R1. R3 is 2R1. If you put R3 is 2R1, then only the product of V1 R3 and V2 R1 will be same and the difference will be 0. So under this condition of V3 as 2R1 and V2 as V1 to V1, then only the difference will be 0. So this is correct answer. So therefore option number D is also correct. So for this question we have 3 options correct. Option number A, B and D are correct. Thank you.